Hello, my dear students. Welcome back to Easy Notes. Today we are going to start our chapter number 2, that is work, energy, and power. So, in first part, that is lecture number 1, we'll be studying about work, energy, and power, and their basic measurements and units. Okay. In the second part, we'll discuss some more things. So, what is work? Basically, what do you mean by work? Work is something when, see here, anything in physics. If you talk about work is said to be done when anything, if I'm applying force on anything, it should move. Okay, it should be displaced. See, I'm applying force here. Is it displacing? No. So there is no work done. I'm applying force here. Is it displacing? Yeah, it is displacing. So there is some work here. Simple. So work is said to be done only when the force applied on a body makes the body move. That is, there is displacement of the body. See here, the man is pushing the wall, but there is no motion. So work will be zero. It is the man is pushing the car, so there is some motion, so there will be some work. Okay, work will not be equal to zero in simple terms. So how do we measure work? Let us consider there is a body, okay, and we are applying a force F. We are applying a force F at some angle theta. Force F at some angle theta. I am applying the force in which direction? In xy direction, at some angle theta from x as well as from y. So this body will move in two directions, in xy directions. Okay, but after some time I see that this body is displaced some distance s, and this body comes here. So what happened? There is a displacement in which direction? In only in x axis. So whenever we talk about any vector quantity, see here, if you talk about any vector quantity, let us consider vector A. So there will be two components. One will be along theta, that will be cos component of that vector, and one will be across theta, that will be a sine component of that vector. So A cos theta and A sine theta. Similarly, F will also have two components. Along theta, that will be F cos theta, and across theta it will be F sine theta. Now, which force is responsible for moving a body from here to here? That is nothing but F cos theta, right? In x axis, to move a body in x axis, which force is responsible? F cos theta. So therefore, what is work? Simply the amount of work done by a force is equal to the product of force and the displacement of the point of the application of force in the direction of force. Simply we can say that work is nothing but force into displacement in direction of force. Okay, or we can say that work done is displacement into force in the direction of displacement. Simple. Both should be in the same direction. Simply, in simple words, displacement into force in the direction of displacement. So what is work? We can write it here. W is nothing but displacement is s, and the force in the direction of displacement will be F cos theta. So you can write it as Fs cos theta. So the formula for work will be Fs into cos theta. So theta is the angle between the force and the displacement. Displacement is here, force is acting here, so theta will be the angle between force and displacement vector. So work done is also a scalar quantity. Simple. What is work? Work is something which is equal to the force and force into displacement. Simple. In terms of measurement or mathematical form, or else normally in theoretical form, what we can say, work is said to be done only when the body is being displaced, when the force is applied on it. Okay. Next, positive, negative, and zero work. When is the work said to be positive, negative, or zero? If theta is less than 90 degree, that is nothing but acute angle. So work done will be positive. Why? Because cos theta will be positive when theta is less than 90 degree. Right? Values of cos theta, that will be 1 by root 3 by 2, root 2. You have studied 1 by root 2. You have studied. Yeah, it will be cos theta will be positive. If cos theta is positive from 0 to 90 degree, so if the angle is less than 90 degree, work done will be positive. If the angle is more than 90 degree, that is nothing but obtuse angle. So work done will be negative, because cos theta becomes negative in the second quadrant. If theta is equal to 90 degree, so work done will be 0, because cos 90 degree is 0. Okay, cos 90 is how much? 0. So what are the conditions for the work done to be 0? The first condition is here itself. when the displacement is normal, that is nothing but perpendicular to the direction of force. When theta is 90 degree, we have studied here. At that time, work done will be 0. Second thing, when there is no force applied, when there is no force, there will be no work. Simple. When there is no displacement, I'm applying the force, but there is no displacement. At that time also, work done will become 0. Easy. Positive, negative, and 0 work. So now we'll be talking about work done by a variable force. See, here the force was constant. Okay, some force F I was applying. But here, with respect to displacement, the force will be changing. So at that time, we can do it as W is equal to integration of Fs cos theta, integration of Fs cos theta. Or we can say that if it comes under graph, it will be area under Fs graph. There will be a force and displacement graph. If you find the area, that is nothing but work done. Okay. So work done by the force of gravity. What is the force of gravity? Gravitational force. Simple. Okay. See, if I drop this object, it is going down. Why? Because of a gravitational force. And it is also displacing, right? From here to here, there is a displacement as well. Due to this force, gravitational force, there will be a displacement. So there will be some work. So what is that work? If a body is dropped from height h, the work done due to force of gravity will be mg into h. Why mg into h? Because gravitational force is nothing but m into g. That is nothing but weight. It is what? Gravitational force is also known as weight. Weight of a body. What is the gravitational force acting on this body? M into g of this body. If it displaced by h, it will become mg into h. Simple. Because the angle will be 0 degree, right? Because see here, the force is acting downwards. Displacement is also downwards. So the angle between force and displacement will be 0 degree. If the angle is 0 degree, cos 0 is how much? 1. So work done will be force into displacement. Simple. Note, work done by the force of gravity is the same whether the body is brought down using stairs, a slope, a lift, or simply dropped, because gravitational work is path independent. See here, the body is here. If I drop it like this, mg into h. If I am taking it like this, mg into h. If I am bringing it like this, mg into h. If I am bringing it like this, mg into h. Simple. In any way, the gravitational force, work done due to gravitational force will be same because it is path independent. However, we'll take only the vertical height, not the path traveled. Okay. Displacement is nothing but a vertical height, right? Initial to final point, distance between initial and final point. Smallest distance are 2. Okay. Next, units of work. How do we measure work? SI unit of work is joule. What will be the SI unit of work? Joule. CGS unit of work is erg. CGS unit of work will be erg. Smallest unit. CGS means small unit, not smallest. It is a small unit. Okay. SI unit is joule. Small unit is erg. Bigger units are kilojoule. Kilojoule means, kilo means wherever word kilo comes, that is nothing but 10 to the power 3. Any 1000 joules. Megajoule. Mega means see here. I mentioned here. 1 kilojoule is 10 to the power 3 joule. 1 megajoule is 10 to the power 6 joule. 1 gigajoule will be 10 to the power 9 joule. Okay. And 1 joule is nothing but if 1 Newton of force is applied to move an object by 1 meter. That is nothing but F into S. The unit of force is Newton and the unit of displacement is meter. If both are 1, the unit of work will also be 1. Simple. 1 joule. Okay. So 1 erg is equal to 1 dyne into centimeter. Dyne is the CGS unit of force. We know that. And centimeter is also a CGS unit of displacement. So 1 erg is equal to 1 dyne centimeter. 1 joule is equal to 1 Newton meter. And 1 joule is also equal to 10 to the power 7 ergs. Okay, if they ask that relation between joule and erg, CGS unit and SI unit. So 1 joule will be equal to 10 to the power 7 erg, or 1 erg is equal to 10 to the power minus 7 joule. You can say this as well. Okay, easy. Next, some questions. A crane pulls up a car of mass 500 kg to a vertical height of 4 meter. Calculate the work done by the crane. Simple terms. How much mass? Mass is 500 kg. Okay. To a height of 4 meter. Height is how much? 4 meter. Okay. What is the work done? They are asking. What is the work done? Work is nothing but force into displacement. So let's solve it. Work is nothing but force into displacement. Which is the force acting here? Gravitational force. See here, the crane is being pulled, right? The same force is acting downwards. We have to pull only the weight of the force, right? So the force applied will be equal to gravitational force. There's nothing but mg into displacement is how much? H. So work done will be equal to mass is how much? 500 into g is how much? 9.8 we can say, or we can say 10. I'm taking here g is approximately equal to 10 meter per second square. Okay, you can also take 9.8. The answer will be slight different. If they have given in the question 9.8, we have to take 9.8. If they have not given, we can take easily 10 meter per second. Okay, so g is 10 into height is how much? 4 meter. So w is equal to 500 into 10, 5000. 5000 into 4 will be 20,000 joule, or we can say it as 20 kilojoule, because 1000 joule is nothing but 1 kilojoule, right? So 20 kilojoule of work is done to pull the car of mass 500 kg. Okay. Next, when the displacement of a body is in the same direction as the applied force, the work done is said to be positive. Simple. If force and displacement is in same direction, the work done will be positive. A force of 10 Newton is required to pull a block of iron of mass 2 kg. Mass is how much? 2 kg. Let us write it here. Mass is 2 kg. And force they have given how much? 10 Newton. Okay. Through a distance of 10 meter. Distance is how much? 10 meter. Okay. Along the inclined plane, making an angle of 30 degree. There is an inclined plane here like this. Okay. At an angle of 30 degree. This is of mass 2 kgs. And you are applying a force here, F. And it is getting displaced here 10 meter like this. This is the actual question. There is a body of mass 2 kg at an angle of 30 degree inclination. We are applying a force of 10 Newton here, which is getting displaced by 10 meter on an inclined plane with the horizontal. Okay, done. Calculate what all we need to calculate. Let us see what all we need to calculate. Work done by the force in pulling the block. See how much work is done in pushing the block from here to here. So simple. First question will solve. W is equal to force into displacement, because they are in the same direction. If they are in the same direction, cos theta becomes 1, because cos 0 is 1. Simple. So W is equal to, what is force? Force is 10. Displacement is also 10. So work done will be how much? 100 joule. Simple. Done. First one is done. Second one, force due to gravity on the body. What will be gravitational force? See, here we need to take G is equal to 9.8. Why we need to take 9.8 meter per second square? Because we are actually calculating the approximate value. Because if we take 10, again the answer will be same. That's why I'm telling you. Okay. Second thing, force due to gravity. What is the force due to gravity? Force due to gravity. Okay. Let us consider simple gravitational force, right? Force due to gravity, that is nothing but mg, gravitational force. So Fg is equal to, mass is how much? Mass is 2 into 9.8. So how much is it? 9.8 into 2 will be 19.6 Newton. This is the gravitational force acting here. Done. Chalo. Next, third question. What they are asking? Third question. Work done against the gravity. Simple. Work done will be gravitational force into vertical height. This is the vertical height, h. Understood? So how can we find the vertical height? Let us calculate it here. Do we know sine theta? Yeah, we know sine theta. Sine theta is opposite by hypotenuse. Opposite is h. Hypotenuse is this 10 meter. Okay. Acha, here it is sine 30 degree, right? Sine 30 degree is equal to h by 10. How much is sine 30? Sine 30 is 1 by 2. 1 by 2 is equal to h by 10. right? So if it goes here, it will become h is equal to 2 ones are 2 5s are 10. That is nothing but 5 meter. H will be equal to how much? 5 meter. Height is how much? 5 meter. Let's substitute. W is equal to gravitational force. How much we got? 19.6 into 5. Right? So if we solve this, 5 6 are 30. 5 9s are 45. 45 plus 3 will be 48. 5 are 5. That is nothing but 98. How much we got? 98. Remove this 0. Simple. 98 joule. 98 joule of work is done by work is done against gravity. Okay. The total work will be 100, but due to gravity it is 98. There is the remaining work of 2 joule. This is this. The work done against force of friction between the block and the inclined plane. The extra work done where the work is being lost. Extra work is done where? While pulling it or pushing it from inclination theta from here to here, there is some extra work done against gravity. Okay, except gravity, there will be an extra work done. Why? Because while moving it from here to here, there is a friction on the surface as well, right? So the extra energy loss, that is nothing but extra work to be done, will be due to friction. How much it is? 100 minus 98. That is nothing but 2 joules. Hope you have understood it. We can easily solve this. W minus Wg will be work done due to force of friction. Okay. Chalo. Next. Assertion and reason. Let's see. When the displacement is 0, then the work done is 0. True. So if the work done is 0, then it is necessarily mean displacement is 0. No, this is false. It is not necessary that only displacement should be 0. Work done can be 0 anytime. If the force is also 0, work done will be 0. If the angle between displacement and force is 90 degree, at that time also work done will be 0. But he's saying that if work is 0, then necessarily means that displacement is 0. That is false. So assertion is false. Here it is true. It is also true. Assertion is true. Assertion is false. Option D only will be the answer. See, let's see. Reason. Work is calculated by relation W is equal to Fs cos theta. Yeah, that's true. This is true and this is false. So assertion is false, but reason is true. Easy? Easy. Chalo. Next thing. Power. What is power? The power spent by the source is measured as the amount of work done per second by the source, or is equal to the rate of doing work by the source. So let us understand here. There are 4 students here. Okay. 1, A, B, C, and D. There are 4 students. I gave them work. What work? I gave them to solve the questions. 20 questions. Okay. I told them whoever will solve 20 questions, I'll give them a chocolate tomorrow. So what happened today? They all went. They all solved the questions. Tomorrow when they came to class, I asked them, did you solve the questions? They're like, yeah, we did. How many have solved 20 questions? They're like, me, and me. Everyone solved 20 questions. But I have bought only 1 chocolate. So what should I do? I should give to only one of them, right? So if I want to give only to one of them, what should I do? At that time, what should I do is, I should ask them how much time they took to solve those 20 questions. If I ask A, how much time you took? He told that I took 20 minutes. If I ask B, I was like, I took 30 minutes. If I ask C, I took 15 minutes. If I ask D, I took 40 minutes. So who is best among them? The best among them is C, who has done more work in less amount of time. So he'll be having more power. Simple thing. So power is nothing but work done per unit time. Work done per unit time. Okay. So we have learned work. What is work? Work is nothing but Fs cos theta divided by time t. Okay. Displacement by time. What will be the displacement by time? Displacement by time is velocity. So we can read as Fv cos theta as well. It will be another formula for power. It will be Fv cos theta. Work done by time, or we can say Fv cos theta. Easy? What easy? Let's move to the next part, that is units of power. What is the SI unit of power? Watt. What is the SI unit of power? Okay. Serious unit is erg per second. Erg per second. Bigger units will be kilowatt, megawatt, or gigawatt. Wherever kilo comes, that is nothing but 10 to the power 3. Wherever mega comes, that is nothing but 10 to the power 6. And giga is nothing but 10 to the power 9. 1 watt. See, anything, any formula, yeah, any unit is said to be 1 when the formula here. See, what was the formula here? That is nothing but worked by time. The unit of this will be 1 when the value of this both will be 1. Simple. See, when it is said to be 1 watt, if 1 joule of work is done in 1 second, simple, the power is said to be 1 watt. If 1 joule of work is done in 1 second, the power spent will be how much? 1 watt. Done. So there is another unit as well, horsepower. It is also a unit of power. So it is another unit of power largely used in mechanical engineering. You have to remember that. That's it. You have to remember the relation between them. 1 watt is 10 to the power 7 erg per second, or 1 horsepower is 746 watt. This is an important thing. 1 horsepower is 746 watt. This 10 to the power 3, 10 to the power 6, and 10 to the power 9, because kilo, mega, and giga refers to 10 to the power 3, 6, and 9. Okay. Next question. Calculate the power of an engine required to lift 10 to the power 5 kg. Mass given is 10 to the power 5 kg of coal per hour. Per hour means time is how much? 1 hour. We have to convert it into seconds. It has 60 minutes into 60 seconds. That is nothing but 3600 seconds in 1 hour. From a mine of 360 meter deep. Distance they have given how much? Simple, h we can take. Deep. Depth how much? 360 meter. And g they have given 10 meter per second square. Okay. Now what we have to solve? Power. Simple. What is the power? Formula for power? Power is nothing but work by time. Work is done due to gravity, because we are lifting. Same force will be same as gravitation. That is nothing but work. That is nothing but mg into displacement is h divided by time t. Mass is how much? 10 to the power 5. G is 10. Height is how much? 360 divided by time is how much? 3600. 3600. So 1 2 zeros, 1 2 zeros will be cancelled. 36 will also get cancelled. So power can be written as 10 to the power 5 watt, or it can be written as 100 into 10 to the power 3, right? 10 to the power 3 is kilo. So it can be written as 10 to the power 100 kilowatt, or 10 to the power 5 watt. Easy. Too easy, man. Chalo. We'll go to the next question. A man exerts a force of 200 Newton. Force is how much? 200 Newton in pulling a cart at a constant speed of 16 meter per second. Speed is how much? 16 meter per second. Calculate the power spent by the man. Pulling a cart in the same direction, simple. So therefore power will be F into V, because cos 0 is cos theta, it will come, right? Cos 0 will be 1 again. So power is equal to force is how much? 200 into 16. That will be 3200 watt. So easy, right? So, next. 6.4 kilojoule of energy causes displacement of 64 meter in a body in the direction of force in 2.5 seconds. Energy means a form of work, right? So 6.4 kilojoule, that is nothing but 6400 joule, right? Into 10 to the power 3, into 1000 we have to do. Causes a displacement of 64 meter. Displacement is how much? 64 meter in the direction of force in 2.5 seconds. Time they have given is 2.5 seconds. Calculate the force applied. We need to find the force and also the power in horsepower. Simple. What is the formula for work? Work is nothing but force into displacement. So what will be force? Force will be work by displacement. What is work? 6400. What is displacement? 64. How much displacement? 64. So 64 into 100 will be 6400. So force is how much? 100 Newton of force. We got to know the force. We need to find power. So what is power? Power is work done by time. Work is 6,400. My time is 2.5. There is nothing but 5 by 2 we can write. So 2 will be up. So power is how much? 6,400 into 2 will be 12,800 divided by 5. So you just solve this, you'll get power in watt. Okay, you'll be getting power in. I'll solve this. Wait. It will be 5 2s are 10, 28. So 5 5s are 25, 30, 5 6 are 30. 2560 watt. It will be 2560 watt. We need power in HP, right? In horsepower. So 1 HP is equal to 746 watt, right? So X HP will be equal to so much watt, that is 2560 watt. You just need to cross multiply and calculate the value of X and comment in the comment section what will be the answer in horsepower. Simple. We just need to cross multiply and calculate the value of X. Easy. Next thing, energy. What is energy? A body capable of doing work is said to be possess energy. Simple words. The capacity to do work is called energy. Okay, the capacity to do work is nothing but energy. So the energy possessed by a body is measured by the amount of work done that a body can perform. How much work a body can perform, that will be calculated as its energy. So the energy of a body is the capacity to do work. Simple. Like work, energy is also a scalar quantity. Energy is also scalar quantity. Okay. So units of energy. Similar to work, units of energy will also be same. That is nothing but joule. Serious unit will be erg, and bigger units will be okay. Here units will change here. Okay, bigger units are also same. Kilowatt, megawatt, gigawatt, same. Sorry, kilojoule, megajoule, and gigajoule. But here there are some two different units. We'll calculate here. See, we told that energy is nothing but a form of work. So we have learned power is nothing but energy by time. We can say, instead of work by time, we can say that energy by time. So energy can be written as power into time, right? Energy can be written as power into time. So what is the unit of power? That is watt. What is the unit of time? That is second. Watt second. Or there is another unit of time. That is nothing but hour. So there is another unit of energy, that is watt hour. Watt hour. Watt hour. Watt hour. Or we can say that kilowatt hour. Power in terms of kilowatt and time in terms of hour. So 1 watt hour is the energy spent by the source of power 1 watt in 1 hour. In 1 hour, how much energy is spent for 1 watt of power? That is nothing but 1 watt hour. So 1 watt hour is equal to 3600 joule. That is 3.6 kilojoule. And 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. 3.6 into 10 to the power 6 joule. It is 3.6 into 10 to the power 3. That is nothing but 3.6 kilojoule. It is 3.6 megajoule. Okay. 1 watt hour is 3.6 kilojoule and 1 kilowatt hour is will be what? 3.6 megajoule. Next is calorie. It is another unit of energy. Heat energy is usually measured in terms of calorie. So 1 calorie is required in raising the temperature of 1 gram of water to from 1 degree Celsius. Simple. Required to raise the temperature of a body or anything by 1 degree Celsius. Okay. So 1 calorie is nothing but 4.18 joule, or 1 calorie is equal to 4.2 joule approximately. You can say 4.2 joules. Okay. Electron volt is also another type of energy. So the energy of atomic particles is very small, so it is measured in terms of electron volt. It will be too small. That's why we will be measuring in terms of electron volt. So 1 electron volt will be 1.6 into 10 to the power minus 19 joule. We need to remember that. 1 electron volt will be 1.6 into 10 to the power minus 19 joule. Okay. The difference between work, power, and energy. What was work? Work done with a force is equal to the product of force and the displacement in the direction of force. Definition simple. What will be power? Power is the source. Power of source is the rate of work done by the source. What is energy? It is the capacity to do work. Work does not depend on time, but power depends on time. Energy spent does not depend on time. Work and energy does not depend on time, but power will be dependent on time. SI unit of work is joule, SI unit of power will be watt, but SI unit of energy is also joule. And all the three are scalar quantity. Neither of the one will be a vector quantity. Okay, remember this. So just revise it completely, copy down the notes, or else you can purchase easy notes from our website. Okay, purchase it, study in that, mark the important things, and keep revising. Okay, so we'll meet in the next lecture. Till then, keep studying and take care. Bye bye.